Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this session, we are going to study problems on Centroid, and we are going to revise by including certain extra problems also in this session. So far, we covered in what is centroid and center of gravity and solved the problems on both symmetrical axes and asymmetrical sections. So in this session, we are going to present completely a revision of the centroid. So with this one lecture, you can understand the complete topic of the centroid very easily. Now, before going to start the centroid, there are certain terminologies to understand centroid, or there are similar terminologies that are there. Center of gravity, centroid, and center of mass. The center of gravity is nothing but the point about which the whole weight of the body is oriented or acting. That point is known as the center of gravity of the particular body. Now here, the center of gravity is having only one center. Each body is having only one center of gravity. Okay, it is represented by the letters G or CG. Okay, and centroid is related to the term of planes. The planes consist of area. The whole is the point at which the whole area of the body is oriented or acting on that. Is assumed to be concentrated. The concentration point, the whole area of the body is concentrated at one point. That point is known as the centroid. So here, what are the figures such as here the simple plane figures? It is mentioned here: rectangle, square, triangle, quadrilateral, circle, etc. Not only these figures, the composite of the rectangles such as I sections and channel section, C section, etc., which is made of different rectangles positioned in such a manner. So these figures, such type of composite figures also can be calculated by using various expressions. Okay, in the case of the centroid, centroid is related to the plane. That means plane means the coordinate consists of the point consists of the two the coordinates x bar and y bar, xy coordinates. Here the centroid is denoted by here xy coordinates as bar x and bar y. This bar x and bar y locates the point of centroid of a plane or composite plane figure. Whereas center of mass, the center of mass means is the point at which the whole mass of the body is concentrated. That point is known as the center of mass. Okay. Here, the centroid, the center of mass, the center of gravity are at the same point. The point is same, okay? But the centroid is related to the term of the plane figures, and whereas center of gravity is related to the term of solid bodies. But generally, some of the textbooks they'll use all are the same, the centroid and center of gravity. Okay, now let us begin. So if you want how to calculate and what is the importance of this centroid, the importance of centroid is in order to calculate the area moment of inertia in parallel axis theorems, and also we need to find out this area moment of the centroid to balance the body, to balance the structures. This centroid is very, very important. Why here it is? The whole body is concentrated at a point. That means if you support that point with the help of some external structure, that body will be balanced completely. That's why this centroid is very, very, very important concept for mechanical engineers. Okay, now let us begin. Whenever we are going to calculate the centroid, now we need the center location of various sections. Here the simple certain some geometries we consider the simple geometries. One is a rectangle, another one is triangle, third one is trapezoidal area, and circle, semicircle, quarter circle, and spiral circular sector. Elliptical area, in that elliptical, semi-elliptical elliptical area, quarter elliptical area, and finally general spandrel. The point is that this rectangle area, suppose if you're considering the section, I section, this I section is having the joint of different rectangles in such a manner, I section is formed here. That means we have to know the individual sections, rectangular sections, centroid. So the centroid is located here. How it is, if the rectangle is having a width A and width A and length B, the centroid is, this is the B by 2, comma A by 2. Okay. Next, if we consider the triangular area, for the triangular area, the centroid is H, where it is. If the reference axis is at this condition, the reference axis at the left side, and here the reference axis, the base reference axis. Because to locate the centroid, we need two axes. Those axes are known as the reference axis. The reference axis are, that is the horizontal. The horizontal reference axis is always considered the bottom, extreme bottom of the structure, extreme bottom of the section, or extreme bottom of the plane figure. Whereas the vertical reference axis is considered extreme left side of the figure, alright, or any plane figures. Now here this is extreme left and extreme bottom. Now here, from this reference axis, if we consider the centroid is at a distance of, we have to know this distance. Here they considered from B plus 2A by 3 by considering here from this right side is the reference. But if we consider the here extreme left side, what is the distance from this centroid? B plus A minus B plus 2A by 3. That is bar X. Whatever bar Y is the H by 3. Okay. And so on. We can go for all this, the centroid of the various figures we have mentioned here. You can go through it. And here, one more thing is that for semicircle, if we consider, what is the semicircle? Here, the semicircle is passing the centroid. If the reference axis is extreme line, and here it is the horizontal, what about point C? A bar X equal to R for semicircle, bar X equal to R, and bar Y equal to 4R by 3 pi. Next, for quarter circle area, here bar X and bar Y equal to, that is 4R by 3 pi. So these are the basics one has to remember to calculate the centroid of a composite figure such as like I section, channel sections, and such sections is known as here the rectangle, the semicircle, and the rectangle, semicircle, and triangle is joined together. If the reference axes are like that, we have to know it individual centroid at distances. Alright. Now here the elliptical area. What about the elliptical area? Area of the ellipse is the pi AB, and what about bar A, centroid, the bar A and B, x bar and y bar, A comma B. Whereas semi-elliptical area, if the reference axis is here, somewhere extreme left side, and whatever bar X equal to A, whatever bar Y equal to 4B by 3 pi. Next, bar X and bar Y here, bar X equal to, whatever from here, this is the reference axis now for this year. If you consider the reference axis, okay, if you consider the reference axis of semi-elliptical area, what about this distance? Bar X equal to A minus 4A by 3 pi, and bar Y equal to 4B by 3 pi. Bar Y equal to 4B by 3 pi. Here we consider here the reference axis are extreme left vertical axis and extreme bottom is the horizontal axis. Alright. So throughout the session we consider like this so that we solve the problems and calculate the centroid of various plane figures. Alright. Now you can go through the circular sector. The circular sector is having the unique portion here. The circular sector is having theta and theta. This is the R. What is the distance of centroid? the distance of the centroid. Here the reference axis is passing through, it is symmetrical about horizontal axis. We are going to discuss this concept now. Now here, what about bar x equal to 2 or sine theta by 3 theta. Okay. Now, and what about bar y equal to, already a horizontal axis passing through centroid, so bar y equal to 0, bar x equal to 2r sine theta by 3 theta. Okay. Thus, you have to go for it. That is a pi AB here, elliptical area. Now, one more thing is that here, what is the areas of rectangular area? The area A here, the width is A and length is B. That is the area of this rectangular section equal to AB. These areas also important. There are two things are important. Three things. One is for calculating the centroid of a particular geometry. One is area of the section, and another one is the centroidal distance of individual section from the reference axis of horizontal distance, and another third parameter that is called x1, horizontal distance x1, and another parameter is called y1. What is the y means? X and y. What is the y is the vertical distance from reference axis. Vertical distance of reference axis. These are the three parameters are required to calculate the centroid of a geometry. Now, suppose if you understand here, this is horizontal reference axis x, vertical reference axis y. Now, this is the area of section A. A is the area of section. We want area of this geometry area, and what is the distance is that? Whatever, this is the G point. What is the centroid of this? G. The distance from vertical axis, this xx and yy are the reference axis. From horizontal distance to here, that is x value, and here it is the y, x and y. So this x distance, that means the centroid from distance x is distance from reference axis, vertical reference axis to centroid, that is the x, horizontal distance. What about y? Vertical distance comes from horizontal axis xx to g. These are the three parameters or three values are required to find out the centroid of a geometry. Alright. Always remember here. Suppose it is a single section. What about multiple sections? Suppose, very important, another concept in this case of centroid is that here same geometry, certain geometry is there. The area of the geometry is area A, the reference axis xx, and here it is yy. Now, suppose here the reference axes are at a distance very far from the section. It is the G point. If the reference axes are passing through the G point, that is the point, the centroid point, there is the reference axis, suppose. Then what about bar x and bar y? Bar x and bar y passing through, what is the bar x means? What is the bar x? Bar x, or what is the x value? Here the area is the A. Okay, to understand, very simple. What is the x here? X is passing horizontal axis through centroid, x equal to 0. What about y? Y equal to also 0. If x equal to 0, y equal to, what is x meaning is that the distance of centroid. Here these are the reference axes. Now for this case, don't think, okay, now these reference axes are passing through this centroid point. Then what about x value here? As we have studied here, x meaning, x and y meanings here. X and y here. So x and y, what is the meaning of x? Distance from vertical axis to G point. What is the vertical axis? Distance from vertical axis to G1, 0. What about y? Distance from horizontal reference axis to G. Distance from horizontal reference axis to Z, that is 0. So x equal to 0, y equal to 0. For what cases? It is for two lines symmetry sections. Two lines of symmetrical sections. Symmetrical sections. Okay, we will study now the concept of symmetry. It comes. Now, what is the concept of symmetry? The concept of symmetry is that If you consider a tree, suppose the geometry is same, exactly it is equivalent. Okay. If you draw a vertical line, okay, if you fold it, it is exactly same on left side and right side. Geometry should be same. Then that means the geometry, that section is symmetrical about vertical axis. That means that it is symmetrical about vertical axis. Symmetrical section. So you draw a horizontal line. If you draw a horizontal line, you fold it horizontally, it is not symmetry on top and bottom. It is not same geometry is not there. That means it is not symmetrical about horizontal axis, but it is symmetrical about vertical axis. That's why it is called single line of symmetrical geometry. Single line of symmetry or one line symmetrical geometry. Okay. And if you consider some of the sections, such as the L section, if you consider the L section, if you fold horizontally and vertically, it is not symmetrical top and bottom. If you fold vertically, it is not symmetrical on both sides, left hand and right side. Geometry shape should be same. It is not same. That means this L section is unsymmetrical, both x and y axis. That's why this section, L section, is known as unsymmetrical section. Unsymmetrical section. Alright. So how to calculate for such type of figures or for such of planes, how to calculate the centroid? Now we'll begin with the centroid. Before that, very simple concept is that now it is symmetrical about, this figure is symmetrical about axis y. That means this is the reference axis. It becomes okay. Whatever axis y is symmetrical, so bar x equal to 0. And what to be calculated? Calculated bar y. What is the bar y? If it is area of section, this is section 1 and it is section 2. Section 1 and section 2, there are two sections are there. So A1, Y1 plus A2, Y2 by A1 plus A2. Here A1, A2 are areas of section 1 and areas of section 2. This is a complete section 1. And here is the complete section 2. What is that area of section 2? Area of section 1. What about Y1? Now Y1 means we have to mark individual centroid, that is G1. For this somewhere else it is G2. The distance from G1 to vertical distance. What is the Y1? Vertical distance from individual section G1 to the horizontal reference axis. This is the reference axis. What about Y2? Distance from section 2, gravity centroid point of section 2 to vertical axis, horizontal axis. Y1, Y2 are known, what about A1, A2 are known, substitute here, you get bar Y. What about the X bar and Y bar location? The X bar, Y bar is 0, comma, and the value of this Y bar. Thus, we have to calculate for symmetrical sections. Whereas for unsymmetrical sections, we have to calculate both bar X and bar Y are to be calculated. So what is the derived expressions for bar 1, bar X and bar Y? For bar X, the derived expression is, suppose if there are two sections here, the L section is, there are two rectangular sections are there. Then for that A1 X1 plus A2 X2 by A1 plus A2. What about bar Y? The bar Y equal to A1 Y1 plus A2 Y2 by A1 plus A2. Alright. So what to be needed here? We need area of A1 section 1, area of section 2. Similarly, what is x1 and x2? Yes. For that, what is the, let us begin. What is the first step? Take the reference axis. These are the reference axis. Okay. And here, they are the reference axis. XX and YY. Mark this section 1. What is the length of the section 1 length? A1. A1 is area of the section 1. That area of the section 1 is length 100 millimeters. Rectangular section, length into breadth, that is 20. That is 2000 square millimeter. What about here? Area of the section 2. Okay, area of the section 1, area of the section 2. The length of the section 2 is 80 minus 20. That is 60 millimeter. That is 60 times 20. That is 1200 square millimeter. Next, what is the next step is? We want x1, x2, y1, y2s. What is the meaning of x1? Okay, the meaning of x1 means mark distance of this rectangular section. Whatever this distance becomes, rectangular section. Whatever rectangular section, that is 20 by 2, that equal to x1, half of the distance. Okay, this is the G1, G1. Now somewhere else G2. Okay, for G2, you have to understand here, and this is the G2. This is the distance of x2. What does the G2 means? According to x2, x2 means distance from centroid of section 2 to vertical axis. This is G2. This is G2 from this here. Vertical axis is y. Whatever this distance is how much? From here to here, it is 60 by 2, 30. Here to here is, that is 20 plus 30. That is x2 equal to 20 plus 30, 50 millimeters. x1, 20 by 2, 10 millimeters. What about y1? Vertical distance. Vertical distance of centroidal point, from centroidal point of section 1 to horizontal reference axis. This is 100 by 2. Alright, 100 by, that is b by 2. You have studied a by 2 in before. That is y1 equal to 50 millimeters. What about y2? y2 is 20 by 2. That is 10 millimeters. Substitute these values. Now centroid depends on area of the geometry, and one more thing. What is the next one is? And the distance from reference centroidal points to reference axis. So A1, x1, A2, x2, all are known here. A1, A2 is known, x1, x2. Substitute in the x bar x equation, expression, then you will get bar x. Wait, what about bar y? In the bar y expression, substitute A1, A2, y1, y2. Then we will get bar y. Thus we will calculate. Let us see the answer now. Alright. Now A1, 2000 square millimeters. What about x1? 10, y1, 50. x1, 10, y1, 50. Yes? Then rectangular 2. What is the A2? 1200 square millimeter. What about x2, y2? x2, 50, y2, 10. x2, 50 millimeters, y2 is 10 millimeters. Yeah, substitute here in the expression of bar x, a1, x1, sum of a1, x1 and a2, x2, and sum of areas a1 and a2. You'll get 25 millimeters. Whereas bar y, that is a1, y1 plus a2, y2 by a1 plus a2. Substitute, so simple, direct, you can understand here very easily. Now, if you mark the location of centroid on this geometry, where it will be? Is this on the geometry of the L section or outside the geometry of L section? Let us see here. Bar x is 25 millimeters. These are the reference axes here. The xx and yy. Bar x means horizontal distance, 25 millimeters. This is 20 thickness, approximately here. 25 millimeters line, bar x. What about bar Y? It is 35 millimeters. This is 20. Approximately it is around, yeah, this is bar Y location. Now this is the centroid of the unsymmetrical section, that is L section. So where it is this on the geometry or outside the geometry? It is outside the geometry. The centroid is located outside the geometry. Okay, the centroid is located outside the geometry for this case. Okay, we'll see whether it is located on the geometry also for unsymmetrical section. Here the section is unsymmetrical, alright. So these are the revision we already covered in the previous sessions. Let me give a glance. Now in this session, the figures are connected here. There are various types of simple geometries such as this off circle, that semicircle, triangle and rectangle lamina. You can go through it how to find out the centroid. Alright. So you may call me as, I am pronouncing as centroid for plane figures, and I mentioned here center of gravity. Even though center of gravity and the centroid is the same point, that's why I use the term here. Now you can go through it. There are three sections are there. Section 1, section 2. Section 1 is the rectangular portion. Section 2 is the semi-elliptical, semicircular portion. Section 3 is the triangular portion. Find out A1, X1, Y1, A2, X2, Y2 from reference axis. You have to consider the reference axis. They did not show here. You have to take it reference axis. Extreme left is the vertical reference axis. Extreme bottom is the horizontal reference axis. What about here? Very important here. Always remember terms, fundamentals you should not forget. Bar X1. X1 means from vertical reference axis to the centroid of the section 1. That is the X1 here. G1. This is what here. From G1 to horizontal distance to reference axis YY. That is X1. So what is X1 here? 25 plus 25 times plus 50. Here it is. The total distance is 100 by 2. That is 75. Okay. Area means for rectangular area, length into breadth. What is the Y1? The Y1 is the vertical distance of section 1 to horizontal. That is 50 by 2. 25 millimeters. Similarly, semicircular and triangular portion, you can go through it after calculating A1, X1, Y1, A2, X2, Y2, A3, X3, Y3. Substitute back in bar X and bar Y, you'll get it. Now, what is the geometry here? Now, my point is here, I'm going to discuss. It is also unsymmetrical section. It is neither horizontal about symmetrical about horizontal axis nor vertical axis. Alright. Now, you look at the bar X. The bar X value is 71. This is the 75. Bar X 71.1 millimeters. So it is approximately here. This is bar X distance. What about bar Y? This is 32.2 millimeters. 32.2 millimeters. This is a 50 from reference axis. Vertical distance is 32.2. That means 25 approximately here. This is G. The centroid of section, this bar Y. The bar Y is centroid of this section G here. That is located here, point G. Where it is unsymmetrical section. The point of centroid is on the geometry. It is on the geometry of this plane figure, point G. So, if you hold this G and balance it, you hold this and give support, it completely balanced. Area will be balanced. Alright. So, like the pen will be balanced completely if you keep it here. Yes, location. It is completely balanced. Why it is completely balanced? The support, here the support, the finger is the support to this horizontal. You consider it as some body. Object is completely balanced. Why? It is passing, it is supporting exactly on both sides, left side and right side, both are equal having. So it is completely balanced. When it will be unbalanced, the support is shifted from centroid away, either towards left side or right side, it becomes unbalanced. So it's very, very important concept in the case of automobiles, where the wheel is completely balanced. When it will be balanced, okay, the weights, they will keep it balancing weights equal in equal distance when unbalancing condition comes to make it the balance. So because of the wear and tear, because of unbalancing takes place, that unbalancing will be balanced in the case of automobile front wheels or railways by using certain weights, small weights in different positions on the circumference of the wheel. So it will be balanced. All right. If it is not located exactly, then what will happen? Unbalancing takes place. This unbalancing causes what? Vibrations. This vibration leads to further damage of the components of the structure. All right. That's why the centroid concept is very, very important for mechanical engineers, aeronautical engineers, and civil engineers also. Let us begin the next session. Here, what we studied, the conclusion is that the centroid is calculated, the calculated centroid is on the geometry of the plane. Whereas in the case of L section, the L section is unsymmetrical, both axis X and axis Y, both unsymmetrical. But the centroid is located outside the geometry is obtained. Whereas the unsymmetrical section we consider for this geometry, it is on the body, on the plane. Alright. Now let us go for the next some few more sessions. Yeah, it is the plane lamina. It is known as the circular sector. To find out the centroid of the circular sector, how to find out the radius? The plane is having a radius of 220 millimeters, and the angle is given here, the 60 degree. Okay, it is symmetrical about which axis? It is symmetrical about vertical axis. So bar x equal to 0. What to be found? Bar y. So consider the reference axis is extreme. Yeah, in this case, if you consider it here, okay, all right. What is here? The circular sector is okay. For this case, you can consider extreme left, because for simplifying, we consider it as at O condition. Okay. So bisecting, it is symmetrical about bar y axis. So bisecting the lamina, the centroid lies where on the symmetrical axis. So what will be the reference point we are considering when it is comes? Then the bar y equal to 2r sin alpha by 3 times alpha. Here what is that alpha? Alpha should be in radians. That is alpha equal to, that is theta here. That is 2 alpha equal to 60 degree. What about alpha equal to? 1 alpha equal to 30 degrees. So 30 degrees equal to pi by times 6 pi by 6 radians. Substitute here is very simple. 2 times r, radius is 220 millimeters. 2 times 220 by 3 sine 30 by pi by 6. Then it becomes 140 millimeters bar y. So bar y means here, how to look at? The bar x equal to 0 and bar y equal to 140 millimeters. So the reference, for especially for circular sector, we go for reference axis at bottom. Why we can consider extreme bottom? So extreme bottom means what? It becomes complexity from here. So for simplification, we consider for this only this case study at O. So here it is located, where it is located 140 millimeters. So approximately will come here. This point is the G. The sector will be balanced, the balancing point. Another point of centroid is known as the balancing point, the point at which the whole structure will be balanced completely, both that is called kinematically equilibrium, or according to the equilibrium equal weights. Okay. Now here, let us come to certain sections as a T section. For the T section, if you want to calculate, now this T section is symmetrical about axis Y. So definitely for symmetrical sections, the point of centroid lies, where it will lie? The point of centroid lies on the symmetrical axis, axis of symmetry. So for symmetrical sections, what about here? Look at the centroid, they ask. So that means symmetrical about axis YY. That's why it is bar x equal to 0. What about bar Y? That is A1 Y1 plus A2 Y2 by A1 plus A2. Alright. Now this is section 1. The rectangle ABCH is considered section 1 and it is section 2. So in the case of ABCH, what is the area? We want x1, y1. There are 3 things are required, 3 parameters, 3 values are required. What is here? The reference axis is considered for vertical axis is the centroid, that is symmetrical axis. What about another horizontal axis? Extreme bottom. So this is the G1 and G2. Okay. Not only total geometry centroid lies on the symmetrical axis, and also individual geometry, local centroids also located on this symmetrical axis only. On this axis of symmetry lies on the axis of symmetry. Now here, what is happening here? What about y1 we need? What is the y1? This is g12 distance, reference axis. This is y1. What about y1 here? That is 150 minus 30. Then this distance will come 120. 120 plus 30 by 2. y1 equal to 120 plus 30 by 2. Then 135 millimeters. Yeah, we got it. This is here they represented that 150 minus 30 by 2. That means top is subtracted from out of 150. Now here next y2. What is the y2 means? Distance from G2, local centroid G2 to local section. That section 2 centroid to distance of reference axis. This is y2. That y2 means whatever here distance is 120. That means y2 equal to half of this is a rectangular section. This 120 by 2, that is 60 millimeters. Okay, this is y1 equal to 135 millimeters, y2 equal to 60 millimeters. Now 60 millimeters, 135 millimeters, substitute in where? Derived expression, that is a1 y1 plus a2 y2 by a1 plus a2. Then the axis comes here. What is the bar y distance? 94.1 millimeters. Now how to locate here? This is y axis, and that axis what about horizontal distance? From here 94.1 millimeters, approximately here 94.1 millimeters. So bar x and bar y, what is the bar x and bar y? 0, 94.1 millimeters. That's the location, the centroid, point of location of the centroid of single line symmetry, that is T section. So here we can understand, suppose if the section is symmetrical about horizontal axis, then bar y equal to 0. It is symmetrical about horizontal axis. Here by looking at the coordinate we can understand, if it is a bar x equal to 0 means symmetrical about vertical axis, bar y equal to 0 that means that section symmetrical about bar y equal to 0, symmetrical about horizontal axis bar y, that means there is no vertical distance. So that is for symmetrical about horizontal axis. Okay, that is what we can understand. By practicing you can understand it. Now here as we mentioned, the channel section, for this channel section is symmetrical about horizontal axis. They did not mention anything. Find the centroid, that's it over. You have to understand by looking at the section which one is 0. If it is symmetrical about horizontal axis, which is symmetrical about horizontal axis, that means bar y equal to 0. What to be calculated? Bar x. Bar x means a1 x1 plus, there are 3 sections, a2 x2 plus a3 x3 by sum of areas a1, a2 and a3. What are the 3 things are required here? Areas of individual sections and x1, x2, x3. Let us see here. Yes, that's what. A1, x1, A2, x2, A3, x3. It is symmetrical about horizontal axis. So, it is symmetrical, that means this x-axis is passing through where? The centroid of the channel section. Now, centroid lies where? On this axis of symmetry. Now, if we calculate the bar x value, this is a reference axis, the bar x value calculated. The bar x we got it as 17.8 millimeters. Where it is located here? The 17.8 millimeters. The thickness is 15. Alright. That means it is outside this geometry. This is the centroid of the channel section. Now, very important point you can understand here. For unsymmetrical sections, the centroid can be outside the geometry or on the geometry. Similarly, not only similarly here, for symmetrical sections, for single line of symmetry, if we consider the single line of symmetry, the centroid, the point of centroid can be on the outside the geometry or on the outside the geometry or on the geometry, but it can also be, but only one condition is that it is on the axis of symmetry. Okay, definitely it is on symmetrical axis of symmetry here G. But that axis of symmetry, that the point of centroid can be outside the geometry or on the geometry also. But very important is that if there are two lines of symmetries are there, two lines of symmetry of any section you take it. For I section, okay, definitely it will lie on the geometry only. Centroid lies on the geometry only for two lines of symmetrical sections. That is very important. Alright. Now, this is what here. This section is symmetrical about vertical axis, but it is on this axis of symmetry. Definitely on the axis of geometry here. Then where is the location of the center? Now, here it is symmetrical about axis YY. That means bar x equal to 0. What do we calculate at bar y? How it comes bar y? Again, section 1, section 2, section 3. Then bar y equal to A1 y1 plus a2 y2 plus a3 y3 by a1 plus a2 plus a3. Thus, we have to calculate, okay, what are the things are required? Area of the section 1. Here, one terminology you have to understand. For I section, there are the terminologies that this is top flange, F-L-A-N-G-E, and here it is bottom flange. And what about this middle portion is known as the web portion. There are two flanges are there, top flange and bottom flange, and here it is the middle portion, vertical portion is known as the web. This terminology is highly useful for calculating the moment of inertia of I section and centroid of the I section. Here, it is not top and bottom flange are not equal in geometry. The dimensions are not equal. Alright, what about A1? Here I think bottom flange is considered as the section 1 and the web is considered as section 2 and the top flange is considered as section 3. Yeah, find out A1 Y1, that is area of the section 1, bottom flange is 100 times 300. And what about Y1? Distance of this G1, this is the distance of G2, here it is G3. This is the reference axis. First to locate the reference axis. Now noted vertical axis. Alright, now from this G1 to this distance Y1, G2 to Y2, G3 to Y3. Yes, what about G1 is 100 by 2, 50 millimeter. What about Y2? Y2 means 100 plus 300 by 2. What about Y3? 100 plus 300 plus 50 by 2. Substitute A1, A2, A3, Y1, Y2, Y3 and so on. Then you will get it. The bar Y value, that is 160.7 millimeters. Okay, 160.7 millimeters. Now where it lies? The bar Y means vertical distance. This is the reference axis. Bar X equal to already parallel. Here 160, 100 approximately here. There is the bar Y distance. At that point, if you support this section, it will be balanced both the top and bottom, left and right. Already left and right is balanced, right? Because symmetry. Alright. Now, these are the certain things we have studied. And what is the definition terminology in coming section we'll study here. So, we followed certain references also here, Hibler and Irving and H. James, like that. Okay. Let me conclude here. What we revised in this session is that what is centroid, what is center of gravity and center of mass, what is symmetrical section, what is the meaning of axis of symmetry and unsymmetrical section, and also calculated the centroid of both symmetrical sections and unsymmetrical sections also, single line of symmetry and two lines of symmetrical sections also. And one more very, very important is that we have studied the location or the properties of centroid of various sections. For two lines of symmetrical sections, it lies on the geometry. Centroid lies. The point of centroid lies on the geometry. L-I-E, okay? Lying. And whereas for unsymmetrical sections, the location, the point of centroid can be on the geometry or outside the geometry also. For single line of symmetry also, the location of the point of centroid can be on the geometry or outside the geometry. But for the case of single line of symmetrical sections, the centroid definitely lies on the axis of symmetry. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.